Myself K. Vijay Kumar. I am from Mechanical Engineering. Today I am explaining about Introduction to a Physical Contradiction in Network Theory. Network theory is a field of study that explores the behavior and properties of interconnected systems. Physical contradictions can arise when the principles of network theory clash with the physical constitutions of the systems. In the presentation, we will discuss a specific physical contradiction in network theory and its implication because successful outcome goal requires, and the figure is showing that improved parameter and physical parameter plus a and version parameter 2 physical parameter minus a, in conflict 1 and conflict 2 and conflict 3 and conflict 4 all are both four sides are in opposite direction, and the one is physical contradiction, and the successful outcome is improved parameter 1 and worsen parameter 2, and then the technical contradiction. And the next topic is definition of network theory. Network theory is a branch of mathematics and computer science that deals with the study of complex networks. Network theory is a branch of mathematics and computer science. It provides a framework to analyze and model the interconnections between various elements or entities in a system. It provides a framework to analyze the model of interconnections between elements or entities initiates in a system. The theory aims to understand the emergent properties and dynamics of these networks. This theory aims to understand the emergent properties and the dynamic these of networks. And the next topic is physical constraints in network theory. Physical constraints are limitations imposed by the real world characteristics of the system under study. Physical constraints are limitations imposed by the real world characteristics of the system under study. These constraints can involve the factors such as physical space, energy, combustion, communication delays, or material properties or like those, etc. These constraints can involve the factors such as physical space, energy consumption, communication delays, or material properties. Network theory often assumes an idealized setting, neglecting these physical constraints, which lead to contradiction. And the physical contradiction is in network theory arises when the network design or behavior violates the physical constraints of the system. The physical contradiction is in network theory violates the physical constraints of the system. The contradiction can manifest in various ways such as insufficient bandwidth, limited range, and excessive power consumption or signal interference. It highlights the need to consider the physical aspects of the system when analyzing and designing networks. It highlights to need the consider of technical aspects of the system when analyzing and designing networks. Physical contradiction and technical contradiction. Example: bandwidth constraints. In network theory, bandwidth refers to the data transmission capacity of a network link. However, the physical constraints such as the available frequency spectrum to the transmission mediums characteristics can limit the achievable bandwidth. This contradiction arises when the network theory assumes unlimited bandwidth, leading to unrealistic expectations and performance degradation in practice. Example range limitations. Example of range limitation. Network theory often assumes infinite range for communication between network nodes. Network theory often assumes infinite range for communication between network nodes. However, the physical constraints such as a signal attenuation or interference impose a finite range on wireless communication. This contraction can lead to communication fails or reduced network coverage when the physical range limitations are not considered. What are the limitations of a limitation? Range is not based on each and every observation of the distribution. Range is not based on each and every distribution of the every observation on the distribution. It is subjected to fluctuations of considerable magnitude from sample. Range cannot be computed in case of open end distributions. Range cannot be computed in case of open end distributions. And the range cannot be computed in case of open end distributions. Range cannot tell anything about the character of the distribution within two extreme observations. Range cannot tell anything about the character of distribution when two extreme observation. Range is not based on each and every observation of its distribution. It is subjected to fluctuation of considerable magnitude from sample. Example of power consumption. Network theory was overlook the power consumption of network components and assume unlimited power availability. Network theory may overlook the power consumption of network components and assume unlimited power availability. However, physical constants such as limited battery life or power supply capacity require energy different network designs. This contradiction becomes evident when network theory fails to account for power consumption, leading to unrealistic expectations and reduced performance. These are the examples of power consumption. Implications, implications of physical contradictions. Ignoring physical constants in network theory can lead to subo- suboptimal network designs and unreliable system behavior. It can result in wasted resources, increasing energy to consumption, reduced performance, or even system failures. By acknowledging and addressing the physical contradiction, network designs can help develop more realistic and effective network solutions. Physical contradiction. A physical contradiction is a conflict between two mutually exclusive physical requirements to the same parameter of an element of the system. Technique used to resolve physical contradiction. Separation, satisfaction, bypass. There are four separation principles to overcome physical contradiction: separation in time, separation in space, separation in condition. Sometimes it is possible to fulfill two contradictory requirements using the new effect. It is most cases and it is near necessary to radically change the structure of the system. Sometimes it is possible to bypass both contradictory requirements and with the use of system operator mind windows to the L make observations to the system on a level of element systems and superate the various times are operating to find opponents by the bypass the problem. These are the examples of implications of physical contradiction. Overcoming the physical contradiction to overcome the physical contradiction, network theorists must integrate physical constants into their models and analyses. This requires interdisciplinary collaboration with experts in physics, engineering, and other relevant fields. By considering the physical aspects of the system, network theory can provide more accurate predictions and guide practical network designs. To this requires interdisciplinary collaboration with experts in physics, engineering, and other relevant fields. By considering the physical aspects to system, network theory can provide more accurate physical guide partial network design. Design considerations. When designing networks, it is crucial to account for physical constraints from the beginning. This includes the understanding the limitations of transmission medium, power availability, signal propagation, and other relevant factors. By incorporating these considerations, network designers can develop more realistic and reliable network architectures. Case studies. Several case of studies demonstrate the importance of addressing the physical contradiction in network theory. For example, wireless sensor network in remote areas face challenges related to power, and by considering these physical constraints, breaches have developed energy efficient to reach the protocol routing algorithms to optimize network performance. Future directions. Addressing the physical contradiction in network theory remains an ongoing science. Future studies aim to develop more comprehensive models that integrate physical constants seamlessly. Additionally, advances in technology such as new wireless communication standards or energy efficient components can help mitigate the physical contradiction.